Welcome back to the flipped classroom. Our topic today is called complex fractions. So, what is a complex fraction? Well, it's really just a fraction within a fraction. So perhaps that sounds a little intimidating, but follow the steps and it'll surely be okay. So our goals are to turn every term into a fraction. This will in fact make it easier. Find a common denominator, multiply every term by the common denominator, and then factor and simplify. So here's our first example, 2 over 3x divided by 1 over x. So hopefully you can see what I mean by a fraction within a fraction. Here's our main fraction, and we have a fraction in the numerator, a fraction in the denominator, and the whole question's a fraction. So hence the term complex fraction. Our goal is to focus on just the denominators. So I'm going to look at this denominator and this denominator and ask myself, what do they have in common? Well, since they're monomials, I'm just looking for the number and variable. I see a 3 and an x. So I would say my common denominator is 3x. Now that I have that common denominator, I'm simply going to multiply the top fraction and the bottom fraction by 3x. Notice when I write it, I'm putting it in the numerator of the top fraction and in the numerator of the bottom fraction. Now, the whole point of doing that is in the hopes that I kill the fraction. So you'll notice this 3x and this 3x on this fraction will cancel. So in this whole top part, I'm left with just the number 2. And you'll notice this x and this x will cancel. So I'm left with the 1 times 3, which gets me a 3. So my final answer is 2/3. Phew. Now, if you're still feeling a little fuzzy on that, we're going to do quite a few examples today, so stay with me on each one. This is a pretty big topic for us. So let's give another one a whirl. Number 2, x minus 1 over x all over x plus 1. So if you flip back to your notes, the thing I said first, our goals there, is we want to turn every term into a fraction, and this will make it easier. So you can see that this is already a fraction, and I can easily make this a fraction by putting it over 1. And I can make this a fraction by putting it over 1, and this term a fraction by putting it over 1. And now I'm just going to focus on my 4 denominators. Well, 1, 1, and 1, clearly the number's 1, and the variable x. So I would say my common denominator is 1x. Now, of course, you don't need to say the 1, you can just say x. But I just want to stress 1x as my denominator. So I'm going to multiply all 4 terms by 1x. Alright, so you can see I've got my x's next to every term, and of course I'm putting them on the top. Now the goal is to kill any fraction if I can. So if I look carefully at this fraction, I have an x on top and a 1 on the bottom. Nothing will cancel, so I'm just going to multiply them together to get x squared. On the second fraction, though, here's where that killing the fraction comes in. This x on top and this x on the bottom are gone, and I'm left with a minus sign and a 1. On the bottom here, nothing can cancel, so I've got x squared. And again, nothing will cancel here, so I've got a plus x. Now, before I try to simplify, remember you have to factor before simplifying. Okay, so I can't just cancel this x squared and that x squared. Doesn't work that way. I have to factor. So on top, hopefully you see some dots, difference of 2 squares. So I'm going to say that's x plus 1 and x minus 1. On the bottom, not dots this time, x and x tell me GCF. So I can pull an x out, and I'm left with x plus 1. Now something should cancel, and you'll see the x plus 1 on top and the x plus 1 on the bottom cancel. So on top, I've got x minus 1 all over x. And here is my simplified fraction. Alright, let's try another one. I've got x plus 2 over 1 plus 5x plus 6x squared. So you can see this complex fraction. I've got this main fraction, and then I have these fractions sitting inside of it. So again, that's why it's called a complex fraction. So I want to rewrite every term so that it looks like a fraction. And that's very simple. Anything that's not a fraction, I'm just going to put over 1. So x over 1 plus 2 over 1. Got my 1 over 1. And then these guys already are fractions, so I've got my 5 over x plus 6 over x squared. So I'm only focusing on the denominators of each term to find that common denominator. Don't really care about the numerators right now. So if I look at the numbers, I've got 1, 1, and 1, so my common number's 1. And I have an x and an x squared. Now remember, you have to pick the one they both go into. Well, x can go into x, but x squared cannot. So I've got to use x squared as my common denominator. So I'm going to multiply all 5 terms by x squared. So you'll see I have all my x squareds next to all 5 terms. And my goal, again, is to kill the fraction if I can. So in this fraction, nothing cancels. X squared on top and a 1 on the bottom. So if I just multiply, that's x cubed. Second fraction, nothing cancels. So that's 2x squared. On the bottom, nothing cancels. So I've got my x squared. And now here's where we have to pay close attention. This x squared can cancel with this bottom x, and I'm left with just an x. So I'm going to say plus 5x. And now these x squareds completely cancel, so I'm left with just plus 6. Now, remember, I'm not done unless I've factored. So I can't just start canceling x squareds. That's not allowed. I've got to factor first. So on top, I can plot an x squared, and I've got my x plus 2. And on the bottom, remember this is your add, multiply. I'm going to say x plus 3 and x plus 2. Multiplies to 6, adds to 5. And lastly, I can cancel anything that's the same on the top and bottom. So x plus 2 and x plus 2. So I've got x squared over x plus 3. Now I can't cancel that any further because this is being added. And remember, we're only canceling when we're multiplying terms together. All right, let's try another one. And boy, can these start to look ugly. X to the negative 1 plus y to the negative 1 over x to the negative 1 minus y to the negative 1. So one more time, let me just remind you, you cannot cancel these because we're adding, and you can only cancel when you're multiplying. So hopefully these negative exponents stick out to you, and remember, negative exponents turn each term into a fraction. So I can rewrite x to the negative 1 as 1 over x. And I can rewrite y to the negative 1 as 1 over y. And I'll do the same thing on the bottom. I'm going to say that's 1 over x minus 1 over y. So we turned our problem into a complex fraction. All right, so now that I have 4 fractions, my goal is to check out those denominators and come up with a common denominator. Well, looks like I have the letter x and the letter y. So I'm going to say my common denominator is x times y. Okay, my common denominator is x times y. So go ahead and put that next to all 4 fractions. All right, so I've got my 4xy's, and remember that goal is to kill the fraction. So the x on top cancels with the x on the bottom, and I've got y times 1, which is y. The y on the bottom, the y on the top cancel. So I've got 1 times x, which is going to be my plus x, all over. X on the top and bottom cancel, so I've got my y minus y on the top and bottom, x. Now my last check is there's nothing to actually factor. There's no GCF, there's no perfect squares. I do want to check, are they different by a negative? That's the only thing I could really cancel. Well, it looks like the x's are, but the y's certainly are not. So this is as simplified as I can get. All right, so here I go. I'm going to throw another ugly one at you. 2x to the negative 1 plus 4y to the negative 1 over 4xy to the negative 1 minus yx to the negative 1. Whew. All right, so just take your time, and we're going to turn it into a complex fraction because we have all of these negative exponents. The one thing you just want to say to yourself is, who is this negative exponent sitting on? Is it sitting on both the 2 and the x, or just the x? Well, let's take a quick peek off to the side here. And there's a difference between 2x to the negative 1 and the quantity 2x to the negative 1. In my first example, the negative 1 is strictly on the x. so only the x would go to the bottom. In this example, the negative 1 is to both terms because of these parentheses, so all of that would go to the bottom. So just be careful as you read these. To me, it looks like the negative is only on the x. So I'm going to leave the 2 on top and move the x to the bottom. In the second term, that negative is only on the y, so I'm going to leave the 4 on top and put the y on the bottom. Now careful again, the negative is only on the y, so I'm going to leave the 4 and the x on top and move the y to the bottom. And the negative is only on the x here, so I'm going to say this is y over x. So a lot of work just to even turn it into the complex fraction. All right, so check out all 4 denominators, and hopefully you're saying the common denominator is x and y. So I'm going to multiply all 4 terms by xy. All right, so now what can cancel? Well, x on top, x on the bottom, so that leaves me with 2y plus y on the bottom, y on the top, 4x, y on the bottom and top, so that gives me 4x squared, x and a y squared. Now, remember, this is not my final answer because I have to factor. So let's check out the top. It looks to me like GCF of 2. And I'm left with y plus 2x. And on the bottom, perfect square, perfect square, perfect square. So I'm going to say that's 2x plus y and 2x minus y. And lastly, I'm going to see if anything can cancel. Well, it looks like the y plus 2x and y plus 2x. Now, I just want to make sure that we understand they're the same terms and not different by a negative. The 2x is positive, and the y is positive and positive. So there's nothing negative about them, and they cancel out to a positive 1. So I've got 2 over 2x minus y. Final answer. All right, I've got a few more to go. Please stay with me and take some real good notes here. So again, it looks like I have 5 terms, and I'm going to do one thing and turn this one into a fraction by putting it over 1. Now remember, focus on the denominators. What number do I need in the denominators? Hopefully, you're saying the number 5. And if I compare the variables, xx and x squared, hopefully you're saying x squared by now. So again, I'm going to say that common denominator is a 5 and an x squared. So go ahead, multiply all 5 terms by 5x squared. All right, so here we go canceling. 1x on the bottom and 1 on the top leaves me with 5 times 5 is 25x. And I've got that minus sign. 5 on the top, 5 on the bottom. So that looks like x cubed. Nothing cancels here. So I've got 5x squared. And here comes that canceling again. X on the bottom with 1 on the top. So 8 times 5 is 40. And I've got that x left over. That x squared and that x squared are gone. 5 times 15 is going to be a plus 75. All right, now it's all about the factoring, and we've been doing that for a while. So take a look. I've got an x and an x, so hopefully GCF is calling your name. And I've got 25 minus x squared. I would say GCF again on the bottom. Those are all divisible by 5. I'm going to pull out a 5, and I've got x squared plus 8x plus 15. Now hopefully you notice nothing's canceling because it looks like I can factor again. So I'm going to keep that x, and I would definitely say I have dots, difference of 2 squares. 5 plus x, 5 minus x. And on the bottom, keep that 5. Remember, I have to add, multiply. I would say 5 and 3. X plus 5 and x plus 3. Lastly, I'm looking for anything the exact same on the top and bottom to cancel. And it looks like 5 plus x and x plus 5 should be the same thing. For example, if x was 1, 5 plus 1 is 6, and 1 plus 5 is 6. So they would cancel to the same number. And on top, I have an x and a 5 minus x. And on the bottom, a 5 and an x plus 3. And nothing further can cancel, so that is my final answer. All right, I think I've got 3 more to go. So stick with me again. So we've got 3 over x plus 5 over 2 over x minus 3 plus 1 over x plus 5. Now you'll notice I don't have all these monomials anymore. I have binomials. So I'm going to have to use that whole quantity. And focusing on those denominators, I have an x plus 5 quantity, an x plus 5, and an x minus 3. So I would say I have 2 different common denominators. I need the quantity x plus 5 and the quantity x plus 3. So again, I'm going to multiply all 3 fractions by both of these. All right, so here we go. Cancel anything you can on the top and bottom, x plus 5 and x plus 5. So I've got 3 times x plus 3, so 3x plus 9, x minus 3 and x minus 3. So I've got 2 times x plus 5, so I would say that's 2x plus 10, plus x plus 5's cancel, and 1 times x minus 3 is just x minus 3. I'm going to keep cleaning up. So on top, I've got my 3x plus 9. 2x and x make 3x plus 7. And it looks like I can factor the top. I can pull a GCF of 3 out, and I've got x plus 3. On the bottom, can't factor. There's no GCF there, so I've got 3x plus 7. And nothing's going to cancel. That's just as far as I can go. All right. So looking at this example, you'll notice, again, I have these binomials, but one of them is special, and hopefully this one kind of sticks out to you, because you can, I hope you've guessed it, factor this. So I'm going to rewrite my fraction and factor this one. All right, so you'll notice all I did, I rewrote it and I factored this bottom part, pulling out a GCF. So if I focus on these 3 denominators, whoops, that's our dog Bailey, you'll notice I have a 2x minus 5 and the number 4. So my common denominator is the number 4 and the quantity 2x minus 5. Remember, common denominator means one of everything you see. All right, so again, you'll notice I multiplied by our common denominator to all 4 terms. And the other thing I want to catch is that minus sign. We've got to be real careful that we change subtraction to addition as long as we change the signs after it. So I'm going to have to make this 7 a negative. All right, almost there. Our goal is just to cancel now anything on the top and bottom that are the same. So in my first fraction, I'm going to kill that 2x minus 5, and 4 times 1 is 4. Now I've got this nice plus sign. I'm going to kill the 2x minus 5, the 2x minus 5, and the 4 and 4. So I've got a negative 7. On the bottom, the 2x minus 5 and the 2x minus 5, and I'm going to say that's all over 4x. So my final answer should be negative 3 over 4x. Well, that sums it up for complex fractions. Hopefully you've taken your time and really stressed that common denominator to yourself. Come with great questions tomorrow, and we look forward to seeing you. Have a great night.